This is the electric airplane that Sweden's Heart Aerospace plans to fly next year for the first time. It's a demonstrator for the eventual final product, a 30-seater commercial airplane that'll have hybrid capabilities, meaning that it can fly on fully electric power but have jet fuel as a backup or for extended range. This is the first time they have a real working airplane to look at, and we got to pay it a visit. So let's check it out. Welcome to Säve, just outside of Gothenburg in the west of Sweden. And this is very special because we're here with the Heart Aerospace demonstrator aircraft, which they recently unveiled in order to run proof of concept, test the development of this aircraft. They're calling it the Heart X1, and it's pretty much to scale for what the eventual aircraft, the ES-30, is going to look like, feel like, be like. And we get to be here among the first to see it in person in the hangar here. It's so cool to see this thing come to life. We've been hearing about this airplane for quite some time in the development. It's gone through various iterations in terms of what it will be exactly, and they've seemingly settled on this design where you have pure electric engines on the inboard, so number 2 and number 3 engines, and then number 1 and number 4, the outboard engines, are going to run on conventional aviation fuel, so that you have this hybrid solution. You have a safety margin, you have more that you can do with it. But this one here, they're planning to test it out with just electrical engines and do the proof of concept in terms of flying on purely electric. So there's a lot of development, a lot of iteration, a lot of work still left to do, but we're seeing it come to life here. There's a real airframe. You can go inside, you can look at the avionics, all the work in progress, but how cool is this? Really a new era of green aviation coming to life.
Let's start a run before getting inside. So what you see is that the engines were partially dismantled, but we would have the inboard full electrical engines, and the outboard running on fuel. So that's an hybrid system, fully parallel system, fully independent between electrical and fuel system. Electrical engines are running on the high voltage, and the high voltage is based on batteries, 800 volts batteries. That would be mounted on the back of the cabin, right there. And then this is the cargo, where you would have luggage and cargo area. Then on the outside, what you're going to see that is specific, most of the aircraft, it's like a normal aircraft from the outside. You would have, wings, flaps, aileron. We would use electrical actuators on the surface. This is true for flaps, ailerons, rudder, the H-tab. And I think the novelty is maybe this electrical propulsion for sure, and the high voltage, and this hybrid system. The hybrid system, actually, we intend to fly 200 kilometers on electrical engines, but the hybrid system allows the extended range. So extended range is if you hit 200 and you want to extend the range, or you have to divert, then you have the jet, the fuel system that allows to extend the range.
I see. So is the idea that on a very short flight you could just use electric throughout the process?
Yeah.
Or would you say do some of the more energy intensive parts of the flight with the conventional?
So there is like the takeoff full electrical to be quiet. For sure, after we would have a system that would allow to use both energy in flight. We were looking at 3 concepts of operation: a full electrical. If you're in full electrical, you could either stop or put in a very slow idle the outboard engines, but you can also run them at the same time if you have to increase power. And the landing could be fully electrical, but also with a backup system, with a what we call hybrid standby. The outboard engine on jet fuel would be in standby for potential go-around, or when you need extra power, especially for the go-around. After the operation of the aircraft, further definition will have to be done on how you manage the energy. But yes, the primary intent would be able to offer a full electrical flight. Avionics wise, you're going to see we use the Garmin avionics suite. So this is all the equipment that are flying, that are well known. For the low voltage, this is I would say a classical low voltage distribution. So even in terms of architecture, this is a well-known component. The thing is, we intend also to have a lot of in-house design. So instead of maybe getting those equipment off the shelf, we're also looking at developing some bits and pieces ourselves, in-house design.
This is the cargo compartment. Typically you will have something coming up here, loading the cargo, and then this is all cargo compartment. So this cargo door has to be free of access. And then the batteries will sit down somewhere here. And in essence, this aircraft, the last version will be a little bit longer. And then you will be able to have batteries like from here up to here. So we are not removing seats, we're just making a bit longer, or maybe rearrangement the ratios between cargo compartment, door and batteries. But there will definitely be like at least like 2 meters, 1.5 meters of battery systems. And the final product will have above 4 tons of batteries. Really depends on the final configuration and the energy density of the system.
So then we're going to turn it on. What you see here is a Garmin 5000. So this is the one that we got from Garmin just for these demonstrators. This is, I would say, not the final product we will get. And the main characteristic of the cockpit is that we use the T shape, pilot, co-pilot, flight control panels, and 2 lower display for all the controls. So this is I would say, a fairly well-known interface for pilot flying Garmin. In this, for now, it's not connected to the system. So what we see, we use it as a demonstration. So it's kind of a closed loop behind. But when we're gonna go and fly it, then we would have to interface that with the other system. So there's gonna be a lot of activity of system integration with the Garmin. In terms of operation, for example, we intend to offer all options. Synthetic vision, for example, which is all the synthetic terrain. We intend to also have for operation with very low visibility to have an options for enhanced vision system, which is an infrared camera. We intend also to offer the head-up display, which would be a glass above the head of the pilot, head-up display, EVS.
Nice.
Steep approach for some operation. And yeah, in terms of key operation, I think with an electrical flight, the short range, you need to make sure you're going to be landing. So in terms of operation, making sure that even low visibility or any airport, we're going to be able to land. So steep approach, low visibility approach, I think those are our key functions for the operators.
Right, the low visibility would be especially because you wouldn't want to have a lower dispatch rate reliability because of potential weather.
Exactly, potential weather. After, it's a fly-by-wire for sure. So you got a side stick on the side. Those one are, I think, Airbus side stick. Definitely not the final one. What's going to be the novelty would be engine parameters. When most of the pilot would be, what are the engine parameters or the state of my electrical system, which is something that is just for information, not really developed yet. So I think that's where we're gonna have to also focus for pilots or for the crew to know what's happening on the high voltage or the electrical system. We would have to develop those synoptic pages. So those one are just I would say temporary one that we're gonna have to work out as we mature the architecture. Once again, this is something very common on any aircraft. You have synoptic pages for the pilot to understand what is the status of the system. And that's going to be one of the novelties, is how do you inform the pilot about hybrid system, engine status, leftover energy in the aircraft. For example, here you see kind of a status. You say, I've got 50% charge, 49, 51. And this is the leftover I have, for example, for my total energy. So I'm still in the green, I'm okay, but if I hit the yellow, then I'm going to have to take action, or I'm going to be short in energy. So this whole concept, that's what we're going to have to mature in-house, develop in-house the electrical or hybrid propulsion system. How do you tell the pilot how much energy he's got left? Either you put the pilot in the loop, either you put that in a more autonomous way, fully automatic. Those are questions that we would have to solve.
Yep.
What you don't have here is the lever also. That's a big question.
I was curious about
big
that,
question.
yeah.
It's just missing, but today we use a lever with 4 levers.
Yeah.
But that's a big question we're gonna have to answer, is how many levers do we need? 1 per engine? Or do we have 2 for left and right? Or how do we manage the energy?
Yeah.
And or up to the point where we could say, should we just have 1? Is it something that is operationally acceptable and that can be certified? I mean, in a concept you would just say, I just need 1, I just need power, increase power or decrease power, and the brain of the aircraft would do the math to say, okay, do I use the fuel or do I use the electricity, depending on flight plan and where I'm going. So that's something today. Today in the mock-up we show 4 levers.
That's very interesting. Because I guess with electrical propulsion, you could kind of go back to the drawing board with that too. Potentially, if you could, that it doesn't have to be this thing that goes from 0 to 100, where you on a kind of, it could be something completely different, right?
Yeah. I mean, I think today they go like there is idle, takeoff, max, go around, takeoff.
Yeah.
So yes, these all concepts in essence would stay, but you could design something that either smarter or easier to understand for the pilot. And yet we have those discussions.
This is very cool to go on board the demonstrator, and it's pretty much as it will be. The Heart Aerospace hybrid electric aircraft in service. I'm sure the seats will be a little bit different, but this is the cabin cross section more or less. It's got this 1x2 configuration. I'm already a fan, I love that. And it feels quite a bit more spacious actually than other 1x2 aircraft like ERJ 145 family, for example. You can't exactly make passenger experience reviews from a demonstrator aircraft, but it's a really nice inside and just enough for me to stand. Look at that. My hair grazes the top. So, it works great for me.
The S-30 is a regional aircraft, right? That it carries 30 passengers, so it's really an aircraft for short sectors, regional flying. And airlines over the years, they kind of lost interest in this market segment because the existing airplanes, they are very expensive to operate. And as a result of that, right, they moved into larger airplanes, searching for lower costs, and they had to drop services from regional airports. We pitched this aircraft basically to airlines that have an interest in reopening those regional routes, something they cannot do with existing airplanes in the market. But at the same time, airlines, they are very much under pressure on the environmental side. So if we are able to bring to an airline a product that it's economically viable, attractive, and at the same time addresses the climate challenge that airlines have, these two things together would allow airlines to regrow into the regional space, reopening routes that existed in the past. So the S-30, it's not only an aircraft to replace existing regional airplanes, but much more than that, it's an airplane to really reopen markets that have been closed in the past because no other airplane can do what the S-30 can do. We have established an airline advisory board where we gather input from the airlines on what they need, what kind of characteristics the airplane should have, and I define those characteristics, right, as requirements for our engineering team. So we look at targets in terms of operating cost targets, in terms of performance capabilities, a lot of things related to the product, what kind of characteristics the product should have to make sure that there will be demand for the airplane.
And what are some of the, if you had to mention the sort of top things that you're hearing from them, what are those things? What are the sort of like number one, maybe number two? Like, we want this.
I would say number one and number two are the economics and the emissions, right? These are two huge challenges that airlines have. They have to be profitable, they have to have low operating costs, but at the same time, the biggest challenge that airlines face and will face over the coming decades is decarbonization of their operations. This aircraft, because it incorporates new technologies that will require charging stations on the ground, it will require green electricity availability, right? Because it's only zero emissions if you are using green electricity. So you need the entire ecosystem involved to bring this airplane into operations, right? You need governments investing on green energy. You need the airports investing on the charging infrastructure. So we see some lighthouse regions that are very progressive, right, in the incorporation of new clean technology. And it's on those regions where you have the airline, the government, the airport, everyone working together to expedite the adoption of these new technologies that we will see the initial deliveries of the ES30. But over time, this will happen worldwide.
And we have the power distribution, so we take the power from the battery up to the wing, up there in the wing box, and then from there we distribute it to the charging, which is there, and to the motors on the side. So it goes like this and down there.
So the charging is down here?
Yeah, this is the charging solution. So that is an MCS charging system. So the MCS charging system is a mega charging system, and the megawatt charging system, you have there the inlet, you have there the charger we're using. So this one is a mock-up of the MCS, so that is not the full capability of the MCS, that is only up to 40 kilowatts. So what you need to do is, in the cockpit, you will flip 3 switches basically, which is battery and charging allowed. So we allow charging, so we always have the pilot in control. And once you do that, you will take the plug and you plug it to the charging inlet, and it will work, as simple as that. And you have here the emergency button, which is the red one. You have one similar in the cockpit. So if you have a problem, you just press the emergency button, it will stop the system and safely shut it down. We are aiming for having a megawatt charging system in the aircraft, which is capable of 3.75 megawatts, but we're only going to utilize around 2.5 megawatts out of those for our system. So it should fulfill the 30 minutes turnaround time in our as our design. And also we will have a CCS, which is a combined charging system, which is what you have now in cars in Europe. We'll have that as well with the MCS, so you are able to charge it when you have 3-4 flights per day, or you want to charge overnight. Then you will connect the CCS, and then you will leave it to charge overnight, and it will be ready for the next flight. But if you would like to have fast charging 30 minutes, then you need to use MCS.
And you do the CCS because that's more affordable, I guess, if you can save the money on the...
Exactly. So if you imagine that you have an airport which has like 3 flights per day, why would you need to charge very fast? So if you use a CCS and you deplete the battery, then you will need around 4 hours to charge. And for sure you're not going to deplete the battery that much because you're doing really short hops. So in that case, you will put the CCS charger, give it 1-2 hours or 3-4 hours, depending on how much did you deplete, and then you have the aircraft ready for you.
Such a fascinating process with coming up with this aircraft, all the kind of design considerations, the iterations you have to do, taking into account so many things, from aerodynamics to economics to certifiability. So they were telling me how originally the design had the batteries in the sort of above the wheels, kind of base of the aircraft, which I would guess makes the most sense in terms of center of gravity considerations. But it became clear that for certification, that would make things a lot more difficult. So they've been sort of changing the design bit by bit as they've been building and coming up with this demonstrator. So in this case, they're now looking to put the batteries sort of aft, just in front of the cargo compartment and the tail. So it's a process. It's something where they build, they try, they iterate, they might have to change things a little bit. The final aircraft will not look exactly like this, but probably quite a bit like this. And here, another interesting feature we have is the larger wings. So you have a relatively heavy aircraft, which even with 4 engines would need more lift, and that means larger wings, I'm told. So lots of little considerations like that, really fascinating. And so the plan is for them to build a second demonstrator after this, building upon what they're learning through all the simulations, tests that they're running on this one. And they're looking to do first flight next year. The next one will probably be a lot more like the final aircraft, the ES-30, that we'll see the true final version, but not exactly, maybe more small changes as they sort of fine-tune, hone in on the design. And to see this at this point in the process is so interesting. Really cool to get a glimpse into that, because it's rare that you get a chance to see that on an aircraft, especially an aircraft with such new technology as this. There aren't a lot of other aircraft that are flying like this. Very few, in fact none at the moment. So to see how that comes together is extra interesting. A couple of cool facts that I just learned about this aircraft. One is pretty cool. You think about how with a clean sheet design, totally new technology, building something from the ground up, you can do a lot more. You can rethink some things that we take for granted. And they were mentioning how at one of the air shows recently, they met with a group who advocates for people with reduced mobility, people with disabilities, and they were saying how basically flying when you have a disability, as any of you out there who does have one will know, is pretty much a nightmare. It's really not designed for it. They have to come up with solutions for people who are in a wheelchair, for example, that are less than ideal. So they've had that group working with their engineers, talking to them about how can they build something that's a little bit more designed around that from the ground up. So it's not just patching a hole that you just have to kind of figure it out, but starting with this concept of, well, how do we make this from the start better for people with reduced mobility? So that's really interesting. Now there's an alarm going off. The other fascinating thing, which I think is such a cool fact, is that when this aircraft takes flight, hopefully second quarter of 2025, it's going to be the largest electric vehicle to have ever flown. So that's quite an accomplishment, isn't it? As we head towards hopefully a future with very large aircraft flying on sustainable energy, whether that's hydrogen, batteries, you name it, even SAF. To have this as something that's pushing that forward, that journey towards electrified or green aviation forward, that it will kind of set this new record of something that's electrically powered going into the air, the biggest thing that's ever done so. So we can see that although sometimes progress may feel slow, it is in fact progress that's happening, and it's companies like this that are making it happen bit by bit. I hope you enjoyed this little look at the Heart Aerospace demonstrator. I certainly had fun checking it out. Here's to it meeting all of its targets and more, exceeding them in the future. Thanks for coming along. Here in Gothenburg, I'm Gabriel Lee for Flight Radar 24.